Okay, here we are in the garage. That's my little Camaro convertible. I just put a LT1 Corvette engine and the drivetrain in it. It had the 5-liter throttle body, which wasn't bad, but this thing flies now. And this is my baby Trans Am. I had it for like 12 years. I take it out for a ride once in a while. I'll make a video of this too later. So let's go back to this is my system. This cable here brings the power from the panels up on the roof to this breaker box that it was just an off and on switch. I changed it to 15 amp breakers. It's a 10 gauge wire coming in, and I used 8 gauge wires coming down and going to the outback charge controller. Very, very, very good machine. I'm very happy with it. Right now, maybe you can't see, I don't know. We are getting 37 volts from the panels. Output voltage is 14.6, and we're making about 90 watts, coming in 2.5 amps, going out about 6 amps, and it's in absorb mode. Okay, and then from the charge controller I got the 6 gauge wires going to this box. Again, this was a regular fuse box. I added LEDs to show there's something going on over there. So this one shows that the breaker is on and the charge controller is connected to the batteries. I can turn it off. It will be on because still there is charge in the capacitors, the charge controller, but then eventually it will fade off once the capacitor discharge. Now you can see that it's going to the maximum power point tracking float mode and trying to float. It thinks that the batteries are charged because there is no resistance, and it's trying to float charge the batteries. I'm gonna turn the switch back on again, and we'll go look at the amps. Okay, I will restart the charge sequence again to tell it to go to absorb mode again. He's waking up. He's tracking. What is it doing? It's sweeping the voltage coming in and check the amps, see what is the best voltage that gives the best amps. Well, batteries are almost charged, so it went to absorb mode right away. I have a little load on the batteries right now, which I'm going to disconnect. This is the main disconnect, that if I disconnect it will separate the batteries from all the circuits. And you see how the amperage is dropping right there. Okay, gonna turn the system back on. And this is a box I made. Installed two switches, the amp meter and the voltmeter. This turns the volt reading on. See, we have 14.7 volts on the batteries, and the amps show that I have 0.1 amp, which is the draw on this meter, the voltmeter. So if I put more load on by turning my charge and the two lights that I have here, you'll see the amp draw will increase. There we go. Okay. You see we have almost 2 amps drawing from the batteries. That's the voltage on the batteries, which coincides with the output voltage on the outback. Okay. From this breaker box, the charge controller through the 6-gauge wires go to the batteries, positive, negative. And I have 2 battery banks. This was an old butcher table that I turned into a little tray to put those batteries, and they're secured. And you know, in Southern California we have earthquakes, so this is secured to the wall on the corners, and it's solid, so batteries won't be dancing if earthquake happens or the animals that my dogs knock it over. I got 4 batteries. They're about 180 amp reserve capacity. Deep cycle Delco batteries, very good batteries. Then I got 4 more here and 2 more down here that I'm going to install today. This rack is still, again, tied to the wall, secured, very solid. It was made by my good neighbor Alex. He's a genius in woodwork, and he does all kinds of woodwork. So he did this to me. Very solid, very good. And they're away. This is my workbench. They're secured down there. I'm going to replace these wires that I installed in May. By the way, the whole system was put together in May. And most of the cables came from wrecking yard, like this one that connects this bank to over here, this cable, and so on. Those 2 down there that hook up the bottom batteries to the top batteries, they came from junkyard. As you can see, the paint on the cable. And I saved some money. And I'm gonna install these two batteries that I got down here, and we'll have 10 batteries. This is the 50 amp breaker that comes from the positive to the switch down here. I got two 30 amp delay fuses, which then go to the inverter. It's a 700 amp dimensions pure sine inverter, as you can see. Very good machine. It's not that great efficient as the new MOSFET inverters, but very solid. It handles 1500 watts. I blew the fuses once I tested that, but it handled the load. Okay. I use the system basically for lighting the house. I never use the inverter for any appliances. It's just for emergency or in case of a power failure. But I use it to run my power tools all the time. That works great. I hooked up the wires on the batteries in parallel too. So we have the positives all connected to each other in both banks, as you can see, and the negatives connected all together. Oh, by the way, this is the remote temperature sensor for the battery that through that wire goes to the charge controller. And the charge controller adjusts the volts and the amps based on the temperature of the battery, and also have an inside temperature sensor that compares the temperature to the battery temperature. Oh, my lights charging. This here was the charge controller that came with the Harbor Freight. I like it. I never use it as a charge controller. I'm just using it to light up the lights that I showed you. That one there has 5 watts, and that one there, which is an LED, that's 5 watts too. By the way, don't buy the 110 version of this. It's dangerous. It leaks voltage through the strip between the LEDs, and I don't recommend it. Be careful with those. What I did here, I hooked up a splicer that goes to this cigarette lighter adapter that accommodates 3 outputs. I'm using 2 of them right now to charge my lights. It has a USB. So does this charge controller and the various outputs that you need for different applications. And I have my adapters, different kinds of adapters for different applications. My battery tester. So basically this is the setup I have right now. I thought I'll share it with you. Oh, I forgot to show you. From the batteries, I have the 6-gauge cable going to the shunt, and from the shunt it goes to the low voltage disconnect. I got this at the truck junkyard from a 2007 Freightliner truck for 20 bucks, 22 bucks. What it does, when the voltage drops to 11.5 volts, it shuts down the circuit. It gives you a warning for 1 minute through a buzzer that I have disconnected. And it has the option to switch the banks. If you have another set of banks, through a relay, it will switch to the other bank, while these batteries down here on the other bank are charging. So it's a good unit. I like it. And from here, it goes through my circuit breaker. And through the circuit breaker, through this 8-gauge wire, this is 8x3, very good wire, very good cable, I should say. It runs into the attic and to the sub panel or sub fuse box that I have up in the attic. I don't know if you can see it, it's kind of dark. I have to climb up there to show you that. It's way up there, so I'll make another video and share that part with you guys. This is the charge station, basically. Because the way I have this set up like this on this, because I had this is wood, part of the shelving that you can see in the dog pen or the laundry room. So I installed them on that wood in sequence, from the panels to the breaker, from the breaker to charge controller, from charge controller to this breaker, and then the batteries, and then from the batteries to the breaker to the cable, output, going to the attic. I'm going to replace this 10-gauge wire and install the 8-gauge wire again. Once I installed those panels, these are the panels, 4 watt, and I don't know if you can see here, made in USA, 105 watts, and all the information. And it shows 12 volt or 24 volt, and the output and the open voltage and so on. Okay, I'll take you inside. Oh, before I go inside, here's the box, junction box, very big, roomy. That's the positive, number 0. And that's the negative, this connection here. So if you connect number 1 and number 4 and the 2 and the 6, it will be 24 volts. I'm sorry, strike that, it'll be 12 volts. If you connect number 2 and 4, it'll be 24 volts. This is how they look like. They're pretty good. I'm very happy with them. It has a very good solid frame, nicely made, and the rating is C on it, which is common, UL approved, CE, and they're very good panels. Okay, I'm going to take you inside and show you the lighting for the kitchen. This is my kitchen. Those were the lights that fluorescent lights we had. I'll turn them on. They never works right, those things. And the wife wasn't happy when she was doing the dishes over there. So what I did, I installed 6 10-watt LEDs. And there you go. And they light up the sink. Very good. And also, I installed these flat ones here. These are cool white. Got 5 of them all the way. And I have one warm white that we use it as night light. There's one there, and one there. And I got this switch from Ace Hardware. They were like $2 a piece. So that's for the night light. And this one is for down their counter lights, which they light up pretty good. I will make, as I said, another video and show these at night so you'll see the effect, because I got some light coming on through that window there that doesn't justify these lights. And also I put 2 lights in the pantry with the switch over here, right there, and they work pretty good. The good thing about those little lights are that they're very low voltage consuming, amp consuming, so I used 24 gauge wire. And the reason I put the switch up here, my nieces, my wife, nephew, nieces come here and they like to play with these things. So instead of putting them down here somewhere, I put them up here so they won't leave it on. And also it's out of the way, you won't bump in it. But they're good switches. I like those switches. I got 2 down here under this cabinet. They're out of the way. Those are for those lights. So I got separate switches for them. I got 2, as you see. I can turn this one off, turn that one off, and vice versa. On my other video I'll show you how I made the heatsink for those lights, and the driver that I added to those LEDs that are in there, because they get extremely hot, and if they go above 60 degrees, that's it. The driver keeps the voltage and the amps going to the LED constant at lower amount, so they won't get damaged. And also all the power coming from those batteries may damage those LEDs. So far they're working okay. I'm very happy with them. I may add some more in the future under this cabinet, but with the setup that I have right now, we don't need it. Most of you know that are in solar. It's a different way of life. It's just getting used to it and trying to preserve the power you have for emergencies. Those little lights give up good luminance. I like them. They get kind of warm, but I guess they're warm to the touch, but I guess that's how they are. And I got some more over here in the living room. That the stand lamp there, I got 5 watts light bulbs in there, LEDs. And behind that beam, on the other side, I got the strip of the LED that goes all the way to the end and hooks up to the system. What it does, when we turn it on, I'll make a video, I promise, at night, so you can see the effect of the lights. The lights from the light strip hits up the wall, and it's warm white, it's not cool white. And then you have a mellow reflection from that wall there to this area. But I'm going to add 3 more of those flat, round LED lights in those skylights on the corners over there. So they will reflect their light around and down to the room. I got 3 of them, skylights, and they'll be wired behind the beam all the way to the power source in the corner, and the switches will be behind that beam over there and this one here. Okay, that's about it. If you have any questions, please feel free to ask. I learned from YouTube. I thank all the YouTubers that shared their information. I thought it's time for me to share my information. As I go along, I'll make more videos because I'm constantly upgrading and adding stuff, modifying. Like I got new cables for the batteries to replace these cables. This one here, well made, and these are the interconnect between the batteries. It's a 0 gauge welding cable. It says over there, made in USA. I got 14 of them. I'm waiting for the rest to come in so I can install that 2 batteries in there and replace the rest of the cabling. These are the custom-made radiators for the LEDs in the kitchen. I bought a bar of this for like $5 and made a heatsink for the LEDs. I'll make another video of the components I used and how I did those and share it with you. Thank you for watching and have a good one, guys.